Hello everyone, I'm Shi Wei. So happy to join the RT-Thread Global Tech Conference again. I'm the project manager of RT-Thread Studio IDE, taking in charge of building RT-Thread Studio IDE and other embedded development tool software for RT-Thread users. My talk at 2021 RT-Thread Global Tech Conference was telling about building an easy-to-use embedded IDE. I shared some story about myself and IDE software development, and introduced some detailed features of RT-Thread Studio and our explorations on the VS platform. If you have interest, you can check out RT-Thread YouTube channel. It has been 2.5 years since the first version came out. People are wondering about the progress of Studio is now, and what challenges we are encountered, and how we face these challenges. As a total free of charge software, the ecosystem matters a lot. So I would like to take this opportunity to share with you the construction and the development of the Studio ecosystem. And at the end, some core design ideas in the process of developing Studio will be presented. Well, let's take a look at the overall picture. We are working to make the development mode of Studio in a closed loop mode. While we release the new version, we start collecting the feedback and take time to communicate with users, locate the usage problems, and discover potential bugs, as well as analyzing the real user needs. We will give priority to repairing and improving hidden issues as soon as possible. And at the same time, develop new functions for new needs, and then release a new version again. The whole process is closed loop and iterate rapidly. Here is a review to the release history of the Studio over the entire 2.5 years. The first version was released at the end of 2019, followed by very fast-paced iterative development in 2020, with 13 versions released throughout the year, average one version per month. In 2021, the basic functions have been realized and gradually become stable. So we started to slow down in order to free up some extra energy to tackle some core technology and the overall design and implementation of the SDK ecosystem, such as how to apply web technology in Eclipse and how to build an SDK platform ecosystem. At the end of 2021, we launched the SDK platform to start building the SDK ecosystem. At the same time, we began to apply web technology in Studio to improve performance and UI aesthetics. We have released 4 versions in the first half of this year and plan to release another 5 versions in the second half of this year. Until now, Studio has reached 4 milestones in version 1.0. It's just a base IDE that only supports ST development boards, JLink and ST-Link debuggers, and RT-Thread SDK. The whole software is not very stable. By the time of version 1.1, Studio supported ST's full range of chips and began to support RISC-V chips, added support for CAMSYS DLP debugger, and also supports QEMU software emulation debugging. The most important thing was to complete the new design and the implementation of the SDK platform. In 2.0 version, Studio began to apply web technology on Eclipse to implement the user interface. At this stage, lots of semiconductor manufacturers joined our SDK platform. By lots of tests, Studio became more and more easy to use and stable. Studio will release 3.0 version this year. and the 3.0 version will launch a new software platform ecosystem. Studio will open some APIs for third-party software manufacturers, so they can integrate and provide commercial value functional plugins or solutions with Studio. So far, we have mainly developed IDE products on 2 different platforms. At present, we put 80% effort on the Eclipse platform and 20% to the VS platform. At present, the VS plugin of RT-Thread Studio has stopped maintenance. However, the development of open source RT-Thread Smart microkernel operating system is based on VS Code. So in the future, the RT-Thread Studio VS Code plugin may be integrated into the RT-Thread Smart VS Code IDE. In my view, the Eclipse platform is still more mature than VS Code in the embedded development, ecology, or industrial field. Implementing the same set of debugging-related functions on VS Code may require more cost. It's just like spending time to repeat building wheels. Especially, we know that there are just very few front-end developers who understand the embedded development. Therefore, it would take more time for front-end developers to be familiar with embedded development-related process and business, and with the ability to develop IDEs. The core concept of RT-Thread Studio's ecosystem is co-creation and win-win. RT-Thread Studio has the ability to support chips and development boards from any ARM or RISC-V manufacturers, and chips or hardware of any other architectures. Semiconductor manufacturer or development board manufacturer can home build a corresponding chip development board support package according to the SDK support package production specification defined by RT-Thread Studio. To quickly support a certain chip or development board on RT-Thread Studio, the process is quite easy, simple, and efficient. So it's clear to find out that the ecosystem RT-Thread Studio basically benefits from the RT-Thread ecosystem and the RT-Thread Studio SDK platform itself. RT-Thread ecosystem shares source package and online software package with RT-Thread Studio. Also, we very much appreciate the contribution from the semiconductor manufacturers, as they are providing chip and support packages and the development board support package to RT-Thread Studio ecosystem. Of course, we also encountered some challenges. The first is about the performance optimization, how to make the RT-Thread Studio run faster and consume less resources. The second is about implementing a beautiful and attractive user interface. The user interface of the Eclipse platform has been judged for many years. How to implement a beautiful interface on Eclipse is a big question for many Eclipse developers. Then it's about reusable code resources, so that all resources can be interrelated and coexist in coordination and be easily added to the project and compiled smoothly without any errors or all-ins. Last but not the least, how to set up an IDE development team with very limited resources, or what is the priority for IDE development when we face the talent shortages. The performance challenges are mainly reflected in 3 levels: the programming language level, the Eclipse platform level, and the application level. In terms of programming language, RT-Thread Studio is mainly implemented by Java language. Compared with the C and C++ language, the performance of Java program startup and loading is slower, and it also occupies small memory resources during runtime. At present, Some optimization projects of the Java language are also being put on the agenda, such as the Leiden project, the Dravium project, and the Valhalla project, which are worth looking forward to. In terms of programming language, developers need to follow some necessary coding specifications to ensure high performance of the code when programming. At the same time, JVM parameter optimization can improve performance and reduce resources consumption to a certain extent. Aside from the language level, there has space for performance improvement in terms of platform and UI. In terms of Eclipse platform, if the number of plugins is larger, the software start speed will be slower, and more resources will be occupied during runtime. Therefore, if we can reduce the number of unnecessary plugins or use other language to implement some functions to replace the functions implemented by Eclipse plugins, the performance can also be improved. In terms of specific UI and business logic, on the Eclipse platform, the performance of some graphic libraries is not good, such as the display of large tree data. If the Chrome V8 engine can be used to render HTML and run JavaScript to realize the user interface, the interface performance will be greatly improved. In terms of application, for example, there will be obvious performance problems when compiling large projects. Before each compilation, CDT will regenerate all makefiles once. For a project with thousands of files, it will take several seconds to generate all makefiles once. Maybe it's because the developer of CDT neglected to consider super large projects, or did not use super large projects to perform necessary tests, which can be optimized by optimizing related business logic. As we discussed before, the Eclipse platform's user interface has been judged for many years. The Eclipse community had put many efforts to improving the user interface, but little has changed. The Nebula project is the best example, and the letter table is also proof that Eclipse has done lots of efforts in performance of complex chart controls. Draw2D is the graphic sublibrary of the GEF project. It's good to support for customization, but to be honest, it requires relatively high development skills to make a beautiful user interface. The graphics library provided by Eclipse is not beautiful. If you don't want to use the controls provided by it, you have to implement the controls by yourself, which require quite high development skills, and you need to be familiar with the implementation details of the graphic library framework. At the same time, it will consume a lot of your time. Lucky enough, RT-Thread Studio found a new way to implement beautiful user interface with web technology on Eclipse. We combined CEF and SWT browser to implement a Chrome-based SWT browser control. This control can render HTML while running JavaScript. Through this control, JavaScript and Java can be called in both directions. We first applied this method to the implementation of the RT-Thread setting configuration system. This function was implemented with the SWT graphic libraries before, and now it is re-implemented with web technology. Let's take a look at the difference in effect. As you can see, there are many user interface problems directly implemented by the SWT graphic libraries of Eclipse. For example, The transparency of the board lines cannot be set, and the gray scroll bars appear quite often. All boards can only be in rectangular, rather than show round angle. The menu must be right-clicked to show up. If data is very big in volume, the tree control will crash, and real-time search and filtering of the tree control is difficult to achieve. Let's take a look at the effect of re-implementation using web technology. Compared with Eclipse graphic library, web-related interface technology have a huge advantage. Web technologies can easily realize beautiful user interface, and the implementation efficiency is very high, and the running performance is also very good. The subsequent self-developed functions of RT-Thread Studio will be implemented using web technology as much as possible. Let's look at another comparison of user interface implementation effects. One is implemented by Eclipse SWT and the other is implemented by web technology. It's very clear to figure out which one is implemented by web technology. When talking about IDEs, few people think about the importance of reusable code resources for an IDE. In my opinion, the integration of reusable code resources is very important for an IDE. In my opinion, the integration of reusable code resources is very important for an IDE. Its importance of value accounts for about 40% of the whole project. Why? The essence of IDE is to improve developers' learning efficiency or development efficiency. A rich and coordinated resources library will bring great convenience and efficiency to learners and developers. Abundance and coordination lead to coexist, and both are indispensable. Abundance is reflected in the variety of resources, and the coordination is reflected in the fact that resources can be linked through some internal relationships so that the automatic processing of resources can be well implemented. In order to achieve configurability, resources generally have their own configuration description definitions. In order to coordinate with other resources, they generally have their own version definition and dependency definitions. All these lead to be constrained in the form of specification or standards, so that a configuration system or code generation is feasible. And ultimately, our goal is to add resources or generate code to the project that can be compiled smoothly and present 0 errors and 0 warnings. On the contrary, poor resources management is that when the user adds resources to the project, once compiled, there will be countless compilation errors. It is obviously a disaster for a beginner. IDE itself is a complex software. Embedded IDE is more complicated than common IDE because embedded IDE involves a longer technology stack, and all-round talents who master such a long technology stack are just a few. Therefore, in actual development, the technology stack will be cut into pieces, divided into different parts, and hand it over to different development teams. Companies with limited resources will choose to do only part of them, such as the front part, and the other parts will directly reuse the products made by third-party manufacturers for use. This has advantages and disadvantages. The disadvantage is that the problems of third-party software will be directly brought into yours. Sometimes these problems cannot be solved in time, and some problems can't even be fully solved because you don't have the source code. Finally, I would share the two core design ideas that I usually follow. First, be careful not to fall into the trap of developers' thinking. When designing your system, follows developers' thinking. When designing product UI, follows users' thinking. Second, don't bother users to consider. The less the user needs to consider, it means the more successful your UI design is. User thinking mode and the developer thinking mode are two complete different modes. If you want to build a good product, you need to have both inside and use different thinking modes in different scenarios. When designing a system, try the developer thinking mode and try the user thinking mode when designing the product UI. If the developer mode is still used when designing the UI, the complexity of the system will be directly exposed to the user, which inevitably increases the user's learning curve. For many years, I have been very focused on simplicity and practicality in user interface design, until one day I read this book, explains some very useful design principles and emphasizes usability testing. This book is very helpful for UI design, and I would like to recommend it to you. At the end, I would like to introduce RT-Thread Club. It's an online RT-Thread Club for you to ask questions, share experience, and find the mutual learning opportunity. Any questions while using RT-Thread Studio, create a post on RT-Thread Club. We are more than happy to help you. So happy to get this chance to introduce you the RT-Thread Studio IDE. We are here calling all of you to check out more details about RT-Thread Studio on our website. Download RT-Thread Studio after the conference and give it a shot, and share your experience and feedback with us to help us improve. So, thank you for your time. See you next time.